Let's look at some pre-calculus things we're going to need to remember. You're going to need to remember function notation, how to represent a point on a graph in function notation, how to find the equation of a line from 2 points, and the different ways we can represent a function, graphically, symbolically, which means the formula, numerically, and verbally, which we're not going to talk about that much right now. And you need to remember the average rate of change of a function and remember how to calculate it. So this is reviewing all those concepts. So here's the function we're going to be working with a lot in this lesson, f of x equals x squared. Here's its graph. Here's how we represent the point 1, 1 on the function's graph with the function notation. The y-coordinate can be represented as f of the x-coordinate. So here you see that again. And here is that function represented numerically in a table. X is my independent variable, and f of x is my dependent variable. You also need to remember what a secant line is. A secant line is a line that shares at least 2 points with the points on the graph of a function. When you have a secant line, if you have the points that it shares with the function, then you automatically have 2 points on the line. You can figure out the x and y coordinates of those points by using the x coordinate and then evaluating it at the function formula. And then you can get the slope and the equation of a line as you normally would. So here's the function f of x equals x squared. When x is 2, I know that f of 2 is 4. When x is 1, I know that f of 1 is 1. So the secant line to this graph at those 2 points can be found, the equation can be found by knowing that these 2 points line that line and then just finding the equation of the line as I normally would. I get the slope, which is the change in y, over the change in x, and then I'm going to use one of those points on the line to figure out the equation. So the average rate of change of a function is just a generalization of finding the slope of a secant line between any points. Here I have the point A, f of A, and B, f of B, so I'm just generalizing. And the slope of a secant line between those 2 points on a line is just going to be the change in the y values over the change in the x values, and you should remember this as the average rate of change formula from pre-calculus.